Good evening, everyone. I'm Joseph Kong, and these are my friends, and I am honored to introduce you to a few members of our school's Advanced Robotics Team.
Hello, I am Kenny Sharon.
I'm Kayla.
Hello, I'm Elliot.
I am Kaden Nguyen.
I'm Benjamin Fan.
I'm Daniel Chan.
I'm Kevin Lit.
We are excited to present to you our robotics program and some of the things we will do this year. Our school's Advanced Robotics Team participates in the first LEGO League, or FLL competition, as well as doing microcontroller programming and 3D printing. The FLL includes science, technology, engineering, and math through exciting hands-on learning. As participants, we gain real-world problem-solving experience through a guided global robotics program, building a better future together.
We'll engage with our mentor-based programs that require science, engineering, and technology skills. We'll also understand the basics of STEAM, science, technology, engineering, arts, and mathematics, and apply our skills in an exciting competition while building habits of learning, confidence, problem-solving, communication, leadership, and teamwork skills along the way. We have been competing almost every year since 2016, winning trophies, creating friendships, and once a lifetime experiences for us. Many of us have continued their STEAM education into our high school years and beyond.
Here is a video created by Kayla giving a little taste of what LEGO robotics is like. And here's Kenny to explain a little more about what we do.
We start with building our robots. Every team receives a set consisting of a box of LEGO Spike Prime materials to design and create their own robots with. The teams will build their robots to complete missions on the map and gain points with them. Teams will use the LEGO Spike program to code different actions and tasks for robots to complete. When we finish programming, we bring our robots to the map to complete different missions across the board. Our goal is to get as much done as possible in 2 minutes and 30 seconds. We compete in class as well as against other schools in areas such as robot performance, robot design, core values, and best innovation project. We have a history of making it to the top teams and winning many trophies and awards like you see.
What are we doing this year? This year's FLL is all about the future of sustainable energy and power. Our team will address this year's theme of global challenges, mainly focusing on access to affordable, reliable, sustainable, and modern energy for everybody. This season will incorporate building skills and fun robot activities.
Later in the year, we will also use Arduino microcontrollers for different projects. Arduino boards are able to read inputs, light on a sensor, a finger on a button, or a Twitter message, and turn it into an output, like activating a motor, turning on an LED, publishing something online, etc. The Arduino's framework is based on C++, but it is possible to use it with another high-level programming language. In one such project, we will use a pH sensor and a temperature sensor and program it to be used for the 7th graders' science honors fish tanks. We will also design and 3D print different things throughout the year.
The robotics elective also opens up gateways into industrial level engineering in high school. One of these competitions, Seabridge, is where you have a $20 budget and you need to basically figure out what you need to buy and basically complete in order to complete a course that is basically done by the RC submersive. So with this budget, you also need to figure out your electronics, the actual frame itself, the build, and also any materials that you need to replace or test out. You can also open up other gateways into biomedical engineering. So basically, the Biomedical Engineering Society is basically a competition where you innovate on things such as prosthetics and actual in actual machines and software. You basically have to identify things such as tumors, cancer, and illnesses. That's what is being used by doctors today. You can also, the basis of coding, in this case pseudocode and block coding, that is actually what is used in AP Computer Science Principles, one of these college courses that you take in high school. So that basis of coding is actually being tested, and you can really use that to get a good score on the AP test. So basically that's another competition, similar to CPERCH, but a little bit more advanced. So you can see on the right side, that's the actual build itself. You have access to industrial level engineering gears. So that being electronics, that being software such as SolidWorks, and also machines such as CNC routers and mills and 3D printers.
I remember during middle school, Advanced Robotics was the class. It was the class I was most excited about. And then today's class I was looking forward to. And it's class I had the most fun with. The reason I had so much fun is because robotics opens your creativity, opens your innovation. It gives you problems to really think about and solve outside the box. Not only did it open our creativity, but also opened paths to future career options and future programs that we'd like to take in high school. For example, even classes that aren't directly robotics still benefit from the robotics program here at Warner. I'm currently taking product design, which uses a CAD program called DraftSight, and it's very similar in concept to programs they currently use, and also currently use at Warner called SketchUp. Sorry. Skills built at robotics has helped us with building the foundation for more complex and higher level programs in high school.
To end the presentation, here is a video from one of the first Werner Robotics team members on the impact it left.
7 years ago, I remember trying to decide what elective to choose for middle school. One caught my eye in particular. Robotics was a completely new program when I started middle school, so I was very interested to see how these classes would go. Not only did we work directly with robots that we built and we programmed, we got the opportunity to see all of our hard work pay off in in-class competitions, even region-wide competitions. The robotics program at Warner teaches you fundamental programming skills in a team-oriented and hands-on environment. So as a student, you really feel like you're part of a classroom where everyone is learning and growing together. Classes emphasize creative problem solving and working through challenges, and these are skills that helped to prepare me for high school. Now I'm pursuing a computer science degree in college, and it's thanks to the robotics program at Warner that I was able to spark my interest in STEM and programming, and for that, I am forever grateful for the program and its teachers.
Ladies and gentlemen, we have, again, our current students are those 5 young people who are on your right, and our graduates from last year who also won these trophies that they're holding currently are the 3 gentlemen on the left. And Uyen was a student back in 2016. These programs that we do, that we actually start down in the elementaries and we take to the middle school level, really mean meaningful progress in these students' lives, help them find their passion, help them find new things to do. And I could not be more proud of all of you, and I thank you for just being wonderful students. And thank you for listening.